The formula to calculate box volume is box volume in cubic inches equals L plus 2 times T times W plus 2 times T times H, where L equals length in inches, W equals width in inches, H equals height in inches, and T equals thickness of box material in inches. The reason this formula is used instead of length times width times height is that it takes into account the thickness of the box material. When a box is assembled, the thickness of the material adds to the overall dimensions of the box. Here is an example: box length L equals 10 inches, box width W equals 8 inches, box height H equals 6 inches, box thickness T equals 0.5 inches. Box volume in cubic inches equals 10 plus 2 times 0.5 times 8 plus 2 times 0.5 times 6. Box volume in cubic inches equals 11 times 9 times 6. Box volume in cubic inches equals 594. Therefore, the volume of the box is 594 cubic inches. Note that this formula only applies to rectangular boxes. For boxes with other shapes, a different formula is needed. To elaborate further, understanding box fill calculations is crucial in electrical work to ensure safety and compliance with the National Electrical Code. The NEC specifies requirements for the maximum number of conductors, devices, and fittings allowed in an electrical box. Overfilling a box can lead to overheating, insulation damage, and potentially electrical hazards. The NEC provides tables such as Table 314.16, which provide guidelines for box fill based on the size of the box and the gauge of the conductors. However, knowing how to calculate the volume of the box itself is the first step in determining if it meets the NEC requirements. The formula we discussed, box volume equals length plus 2 times thickness times width plus 2 times thickness times height, provides a more accurate volume calculation than simply multiplying length times width times height. This is because it accounts for the thickness of the box walls, which reduces the usable space inside the box. In the example, the box dimensions were length equals 10 inches, width equals 8 inches, height equals 6 inches, and thickness equals 0.5 inches. Using the simple length times width times height formula, the volume would be 10 times 8 times 6, which equals 480 cubic inches. However, using the correct formula, box volume equals 10 plus 2 times 0.5 times 8 plus 2 times 0.5 times 6, the volume is 594 cubic inches. This difference of 114 cubic inches can be significant when determining how many conductors and devices can safely be installed in a box. To apply this knowledge in a real-world scenario, consider an electrician installing wiring and devices in a junction box. The electrician needs to determine if a standard 4-inch square metal box with a depth of 2.125 inches is large enough to accommodate the required conductors, wire connectors, and a receptacle. The box manufacturer specifies the steel thickness as 0.625 inches. Firstly, calculate the box volume using the formula. The length and width of the box are both 4 inches, and the height or depth is 2.125 inches. The thickness is 0.625 inches. Box volume equals 4 plus 2 times 0.625 times 4 plus 2 times 0.625 times 2.125. Box volume equals 4.125 times 4.125 times 2.125. Box volume equals 36.3 cubic inches approximately. Secondly, determine the volume of the conductors. According to NEC Table 314.16b1, each number 12 American wire gauge conductor requires 2.25 cubic inches of free space within the box. Assume there are 6 number 12 American wire gauge conductors. Total conductor volume equals 6 times 2.25 cubic inches, which equals 13.5 cubic inches. Thirdly, account for the device. A single receptacle requires a volume allowance equal to twice the allowance for the largest conductor connected to it, according to NEC 314.16b4. Assuming the receptacle is wired with number 12 American wire gauge conductors, the device allowance is 2 times 2.25 cubic inches, which equals 4.5 cubic inches. Fourthly, consider equipment grounding conductors. All equipment grounding conductors collectively count as a single conductor based on the largest equipment grounding conductor present in the box, per NEC 314.16b5. If there are 3 number 12 American wire gauge equipment grounding conductors, their total volume is still 2.25 cubic inches. Fifthly, calculate the volume of any splices or cable clamps. For this example, assume there are no internal cable clamps and the volume occupied by splices is negligible. Sixthly, calculate the total box fill. Total box fill equals conductor volume plus device volume plus equipment grounding conductor volume. Total box fill equals 13.5 cubic inches plus 4.5 cubic inches plus 2.25 cubic inches. Total box fill equals 20.25 cubic inches. Seventhly, compare the box volume to the total box fill. The box volume is 36.3 cubic inches and the total box fill is 20.25 cubic inches. Since the box volume is greater than the total box fill, the box is adequately sized for the application. Therefore, the electrician can safely install the wiring and devices in the 4-inch square metal box. This example illustrates how the box volume calculation formula combined with NEC guidelines helps electricians determine the appropriate size of electrical boxes for various applications. Accurate box fill calculations are essential for ensuring electrical safety and compliance with code requirements. Ignoring these calculations can lead to dangerous conditions and potential electrical failures. Beyond simple rectangular boxes, other shapes require different formulas. Octagonal boxes, often used for lighting fixtures, require the manufacturer's stated volume to be used. For custom or non-standard box shapes, calculating the volume can be more complex and may require dividing the shape into simpler geometric forms. The importance of precise volume calculation extends beyond safety. It also affects the longevity and reliability of electrical systems. Overfilled boxes can cause conductors to overheat, leading to premature insulation breakdown and potential short circuits. Proper box sizing ensures adequate heat dissipation and prevents mechanical stress on conductors and connections. Furthermore, understanding box fill requirements is crucial for passing electrical inspections. Inspectors verify that installations comply with the NEC, and box fill is a common area of scrutiny. Proper documentation and adherence to code requirements are essential for a successful inspection. In addition to conductors and devices, other items within the box contribute to the overall fill. These include wire connectors, such as wire nuts and terminals, as well as internal cable clamps used to secure cables entering the box. While the NEC does not provide specific volume allowances for these items, it is important to consider their presence and ensure they do not overcrowd the box. Some electricians use a rule of thumb, such as adding 25% to the conductor and device volume to account for wire connectors and other miscellaneous items. However, it is always best to err on the side of caution and choose a larger box if there is any doubt about adequate space. The material of the box can also impact its performance. Metal boxes are generally more durable and provide better protection against physical damage. They also offer superior grounding capabilities compared to non-metallic boxes. Non-metallic boxes, such as those made of plastic, are lighter and easier to work with, but they may not be suitable for all applications. When selecting an electrical box, it is important to consider the environmental conditions it will be exposed to. Boxes installed in damp or wet locations must be specifically listed for those environments. These boxes are typically made of corrosion-resistant materials and have features such as watertight seals to prevent moisture from entering. In corrosive environments, such as those found in industrial facilities or near the coast, special corrosion-resistant boxes and fittings are required. These boxes are typically made of stainless steel or other alloys that can withstand harsh chemicals and salt spray. Maintaining accurate records of box fill calculations is a good practice, especially for complex installations. These records can be useful for future troubleshooting and modifications. Some electricians use software or spreadsheets to automate box fill calculations and generate reports. These tools can help ensure accuracy and consistency, and they can also save time. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. Changes to the code can affect box fill calculations and other aspects of electrical installations. Continuing education courses and industry publications are valuable resources for staying informed about code changes. In summary, accurate box volume calculation is fundamental to safe and compliant electrical installations. The formula box volume equals length plus 2 times thickness times width plus 2 times thickness times height provides a more precise result than the simple length times width times height method by accounting for the box material's thickness. This, combined with a thorough understanding of NEC guidelines and careful consideration of all components within the box, ensures a safe and reliable electrical system. The example provided illustrates how to apply these principles in a practical scenario. Remember to consult the latest edition of the NEC and seek guidance from qualified professionals when necessary.